Hello, this is Cyprian from Midas IT. In this video tutorial, I will show you how to perform a pushover analysis of a steel structure as per the Euro Code 8 2004. So pushover analysis is a performance-based design method which is used by structural engineers which are doing seismic design, and the objective is based on performance. So the owner and the designer collectively select a performance for the structure, and then the engineer carries out the conventional design process, and then he does a pushover analysis to evaluate if the performance objective has been met. So in Midas Gen, we are using the pushover analysis following to a lot of different codes, and in this video we will talk about Eurocode. And in this tutorial I'll show you the method and the procedure to perform pushover analysis for a three-dimensional steel structure, but I will not show you the modeling phase because this is very basic, and this will be focused more on the design and how to put in place the pushover method. So I'll talk about the different steps here. First of all, I'll talk about the details of the building. I'll perform the analysis and I perform the steel code checking. And for the pushover analysis, I'll show you how to define pushover global control, pushover load cases, how to define hinge properties, how to assign hinge properties, and how to perform the pushover analysis, how to check the pushover curve and get the pushover hinge status results, and also finally how to check and verify the safety verification table. So in this slide you can see the details of the example structure that I will use, the different sections, and the dimensions of the building that I will model. And here you have the details about the model. So I'm using the Eurocode 3 2005. I'm using different materials for column, beam, and brace, and I have different type of loads: the gravity, dead load, and live load, static wind loads, static seismic loads, and you have the different static load cases here in this table on the right. Okay, time to open Midas Gen. Here we are, and to load my model. So I just open the project. So if you don't have this model and also the PDF, I will put a link in the description of this video so you can download it from there. So before I'll do anything, I'll first do a checking of what I have here to be sure that everything is defined correctly. So in the properties you see that I have the column, the girder, and the brace. So if I click on this, you see on the screen that it's highlighted in red, different properties. If I want to view this, I can always activate the section, but for this case I will hide it. Then let's take a look at the static load, so self-weight, the floor load, and let's display the floor load. So as you see, the floor load is displayed like that. So let's take a look at the different loadings to see if everything is correct. So we have a wind load here, which is defined like that. We have another wind load in this y direction. We have a static seismic load defined like that, and another static seismic load. So that's it. So now that I did that, I have to go in analysis and perform the analysis. So because the pushover analysis is carried out in the post-processing mode after completing the elastic analysis. That's done. So now that we did that, I can go to the next step, which is the checking of the steel design code. So let's go in the design tab and go into steel design code, check that the arrow code is the code which is defined. So Midas Gen is using the design code specified here to calculate the capacity of the members in the pushover analysis. So that's why you have to be sure that it's correctly defined. And now that I did that, I'll have to do a steel code check before doing anything with the pushover. So that's done. And actually that's I need to do that because I need to know the class of the cross section. So as you see in this file, the class here plastic, so this has been calculated after you perform the design check, and Midas Gen will use this data as the result in order to calculate automatically the classification later on when you perform the pushover analysis. So you will need to have these data to be able to use the auto class for the cross section. So that's why I'm doing that. So now let's go and define the pushover analysis. So for that, go in pushover, and the first step will be to define a pushover global control here on the left of the pushover tab. So we'll define first the initial load cases, which will be applied prior to the pushover analysis, such as the dead load and live load. So in this global control, I have to choose first my subcase, choose the scale factor. So live load is 0.25 as the scale factor. Add it to here and just click on OK to define that. So let me go back in the global control and show you briefly some section that I forgot to show you. When you are using the Euro code, you have a special section here that appears, which is a reference for the design code according to Euro code. So you have scale factor for the ultimate rotation. So here you can define the wall, which is used when you're calculating the total chord rotation capacity at the ultimate for the wall. So here coefficient used is 1.6. You have the cold worked brittle steel, and you have option also without detailing for earthquake resistance and the smooth longitudinal bars option. So all that are options specific to the Euro code. So if you need to use that, click here. Then there's another thing called secondary seismic elements. So this is used in case where you have primary and secondary seismic elements into your model, because in function of what the code is saying is that for primary seismic elements the coefficient is 1.5, but for secondary it's 1. So the user can define secondary seismic element groups like that, so if you need it. So in this tutorial, secondary seismic elements are not defined, so we are using pushover hinge properties assigned to primary element only, but I'm showing the option in case you would need that. Now it's time to define the pushover load cases. So go here in this tab, and I will define the first load case, the acceleration in x direction. So what I have to do is let's define the increment at 30. Let's consider the p delta effect and also use the initial load. I will use displacement control method. So you see you have two methods, load control or displacement control. and I have to define the master node on which I will apply that. So I will choose this one, the node number 20 on my model, and for the max displacement I will set 0.12 meter. So let's uncheck this option, limit interstory deformation angle, and here use uniform acceleration in dx direction. Have to add that and click on OK to add the first load case. Now let's define the second load case, which is this time in y direction. So this is a static load case, and 30 for the number of increment, also p delta. Use the initial load. I'm using also displacement control. I'm selecting the same master node, this time 0.3, and this is in dy direction this time. I uncheck the limit interstory deformation angle. Okay, I'm using static load case EY with a factor of 1, and I add that and click on OK to add my second pushover load case, and that's done. In the next steps, I'll define the pushover hinge properties for the beams, the columns, and the braces inside my model. So again, in the pushover tab, I have assigned the hinge property, so I will define that first. Let's click on Add to define the first hinge property for the beam. So I input the name beam. This is steel material, and activate two components in translation Z direction and moment Y. And now I can click on properties to view that. So for that it's okay, and for the moment I have to put the class of the cross section in automatic. So this is where I was talking previously when I did the design check. The design check results are used by the software automatically to determine the class of the cross section. So click on OK and click on apply, and I got my first hinge property for the beam. Now let's define the second for the column. So this is also steel. This time I'm using PM and status determination for the interaction type. I have 3 components to activate, and in the properties, okay, this one is okay. Okay, so this time I have to define yield surface property. So you see that different methods used are defined here, and in the component properties I have to put to auto the determination of the cross section, and click on apply to define my second property. And now my third property for the braces. So braces, this is truss type, steel, and there's only one component, and I need also to define the class of the cross section as automatic to apply it, and that's done. So now that I defined the pushover hinge properties, you see that they are displayed like that in the walktree, and they are shown in blue because they are not associated yet with your members. So the next step is to assign the pushover hinge properties for the columns, the beams, and the braces. So there are two methods to do that. So I'll show you the first one first for the column. So first I'll select the column in my model like that, and then I go in pushover, assign pushover hinge property, and assign for beams and for column. So I select column and I click on apply. So now it's defined. So now I'll show you the second method, which is directly to first select like that. So I can double click, for example, on the material to select my girder, and then what I'll do is simply to click on the property here and drag and drop it to assign this second property. So now let's do the same for the braces. Click on the hinge property here and drag and drop, and now all my hinge properties for the column, for the beams, and for the braces have been defined. Now that the hinge properties have been defined, here in the walktree you can find the different assigned hinge property, and you can see the details. So for example, you can see the equations and everything has been calculated. So if you see, for example, the yield strength, rotation, all that was set to 1 previously when you define that, but now that this is assigned to the right member, this has been calculated here, so you can see the real values. Now the model and everything is defined, so I'm ready to perform the pushover analysis. So to do that, you have to go in the task pane in the corner here, and you see that you have some help. So the first thing you have to do is to perform the pushover analysis. So wait a bit, that is complete. Okay, that's done. And now that this is done, you can check first the pushover curve. So let's take a look at the curve. So this is the curve for the first load case, the acceleration in x direction. Let's check the capacity spectrum for the target displacement. I'm using Eurocode, and I want to use horizontal design spectrum with a value of 0.5 for the reference peak ground and 1.5 for the behavior factor. So let's click on draw to draw that again, and that's okay, that's it. So for the detailed formula of the target displacement, refer to the Annex B, determination of the target displacement for nonlinear static pushover analysis, and the target displacement which is obtained from the above corresponds to the seismic demands of the limit state of significant damage. So target displacement of the limit state of near collapse is taken equal to that of the SD multiplied by 1.5. Target displacement of the limit state of damage limitation is taken equal to that of SD divided by 2.5. Now let's look at the pushover curve for the second pushover load case. So again, for target displacement, horizontal design spectrum 0.5, 1.5. Okay, that's still the same, and I have the same. So now that I checked the pushover curve, I can close that. And the next step is to check the hinge status results. So click here, and in this window, so first let's look at the hinge status result for the acceleration in x direction. You can view it for all the steps. So let's look at the step 21. Let's check the status of yielding according to the EC8 in a Y component. Let's display the legend and the deform, apply, and now you see that you have in the post processor the status of yielding. So what you can do is to view at every step what is happening by clicking on this small graph as well. Now let's look for the second hinge status result for EY for the step 29, and you see that in this case you have some area where you see the failure. Okay, and that's all for today's tutorial. Thank you very much for watching. I hope you enjoyed it very much.